In this video, we are going to look at 7.8 Law of Sines. In part 2, we will look at something called the Law of Cosines. So let's first focus on the Law of Sines. It says if triangle ABC has side lengths A, B, C as shown, then the first thing I want you to know, if triangle ABC, this is not a right triangle. So far in this chapter, everything we've done has been a right triangle. So this lesson actually will deal with any triangle in the world. It does not have to be a right triangle. Now this is extremely helpful because not all triangles are right triangles. So we have something called the law of sines. Now it's going to look scary and complicated, but it's actually very easy. Now I need you to see that this is a uppercase A and opposite is a lowercase. Same thing with B and C. So this deals on the fact of ratios. So if you have sine angle A is proportionate to sine lowercase a, that is proportionate to sine angle B over lowercase b. So if you have any of those pieces, you can solve the proportion, but we also have sine angle C over lowercase c. So the sides are ratios, the angle and the opposite sides are simply just ratios. Now what is the purpose of the law of sines? Okay, well that purpose is you can find missing parts of any triangle. Now that is very important that you see that it's any triangle. Now we use trig ratios and Pythagorean theorem and geometric mean for right triangles, but this is going to work for any triangle. So when can you use it? Okay, so there's basically two cases that you can use it. Okay, so first, when you know two angles and any side. Two angles and any side. Now, if you look at this example, they have angle, an angle, and a side. So this is the angle, angle, side case. Now this one, okay, you have an angle, a side, and an angle. So this is an angle, side, angle case. Okay, now over here in this case, when you know two sides and the angle opposite, one of the sides. Okay, now if you look at this one, we have an angle, we have a side, and we have a side, but ASS. Now when we were proving triangles congruent, we called this the donkey theorem. So ASS, I'm not going to kind of give it a smiley face because I have a note here. It says this case can lead to an ambiguous case which you will study at higher level math. So what you have to do is you have to trust me that when I give you problems, I am only going to be asking you for one thing, and it's not going to be the ambiguous case, which you will study much later in trig. So now, before we move on here, I want you just to kind of see why these cases are working. Now, if you look back up at the law of sines, we will be using two of these, like this one and this one, or this one and this one, or the first and the third. So we basically need three pieces to find the fourth unknown. Now the key to this typically is to have the angle and an opposite side. So in this situation, I have angle A and its opposite side, and then I can just pick up the C. Now this one, what you would do first on this one is, since you only have that one side, you would first find angle B here. So why does this one work? Well, it's because you have angle A in lowercase a, so you can actually find angle B. So I'm going to stop the video and let you just see if you can figure out when can you actually use the law of sines.